go ahead and find our A and our B. So we're going to go ahead and look at our y-intercept, which is 0x. We know we're starting off with a y is equal to an a b to the x. All we're going to do then is just plug in our point of 0, 6. B to the 0 is 1, so we get a to be 6. Or you could have remembered from what we said before that a is your y-intercept. That's assuming you're not being slid up and down at all. So we really have this. We still have to figure out b. So that's where we're going to come along, and we're going to actually plug in our other point. So we're going to take this point, which tells us an x of 2 and a y of 3/32. We're going to go ahead and plug that in for x and y. Then all we have to do is go ahead and try to solve it for b. So we'll get rid of the 6. Get rid of the square or the squaring, so we'll take the square root. But remember that your b here has to only be a positive number. So b is only going to be a positive root 8, or positive 8, 1/8. So then we'll go ahead and we'll write our function. Our a was 6, our b was 1/8. Here's your function. Well, we're doing the same thing here, but however, keep in mind we're adding something here. Now, when we are adding here, when we're adding, that affects your horizontal asymptote. Our horizontal asymptote is 72. So that means that C is 72, because we had said before that when C was 0, your horizontal asymptote was 0, and it moves it up or down. And here it got moved up to 72. So we know our C is 72. Now A is no longer your y-intercept because it's being slid up or down. So we're going to take our y-intercept, which is this point right here. We're going to actually plug in our x and our y. That allows us then to be able to solve it for A. B to the 0, you should remember, is 1. So we solve it and we get A to be 353. So let's go ahead and write our problem with what we have so far, the A and the C, and we have this. Now we're going to go ahead and plug in our point. This is our point. That tells us an x and a y. Then we can actually go ahead and solve it for our b. Plug in your x of 1, plug in your y of 248.5, subtract your 72, do a little bit of division, and you get b to be 1/2. Now we're going to rewrite our original problem here, substituting in our a, our b, and our c, and we get this. We're going to go ahead and look at our compound interest formula. A is your final amount, P is your initial amount, your principal, R is your interest rate, and when you're using this, make sure you change your interest rate from a percentage into a decimal. N is the number of times it's compounded per year, so if it's compounded quarterly, that's 4 times a year. T is your time in years. So here we're investing $1,000 at 7% compounded monthly for 20 years, and we want to know how much we'll have. Your initial investment is $1,000. That's what P is. R is your interest rate as a decimal, not as a percent. So remember, you move your decimal point over 2 spots. T is your 20 years. Since it's compounded monthly, it's compounded 12 times a year. Then all we have to do is go ahead and substitute those values into your original problem. So you're going to replace your 1,000 with P. You're going to replace R, replace N, and then replace your T with your 20. Then all you have to do is just type it into your calculator. When you're typing it into your calculator, since your exponent has more than one thing, you need to have the whole exponent in parentheses. Since we are dealing with money, you'd want to make sure you go ahead and round it to 2 decimal places.